Hello everyone, welcome to my YouTube channel. Today we will be learning about how to write a great software. Let's start with understanding what is a software. Let's talk about YouTube. So whenever you open YouTube, you see a list of videos. So by default, it is showing you a list of videos which you can view. And whenever you type any title in the search bar, and then it shows you the relevant list of videos to whatever you type. So what is it doing? It is executing the required task, which in this case was showing you list of videos according to whatever input you provided. So coming to the definition, software refers to set of programs or instructions that allows users to perform a specific task. So these programs or instructions are what we use to operate computers so that they can execute the tasks which we want them to. So why does the quality of a software matters? Now we have understanding of what is the software. Let's talk about why does the quality of software matters. So first point is customer satisfaction. If your software is of good quality, then your customer will be satisfied. They won't see any issues, they won't see any lags. They will see it as a smooth experience, easy to use and good user experience. A quality software is very easy to use and it provides a good user experience and they quickly become familiar with the software, easy to update and maintain. So if your software is of good quality, you wrote good quality of code, then it will be very easy to update your software with new requirements and it will be very easy to maintain it in the long term. So if your software you have built of a great quality, then it will be able to handle the real world tasks. So if you just simply test your software with simple use cases, then it won't be of great quality. But if you test your software with real world scenarios, then your software will be of higher quality and it will be able to handle real world tasks. Now, after discussing why do we need great quality in your software, let's talk about what do we need to do in order to ensure that your software is of great quality. So first thing is requirements. So you have to take requirements. So coming to the points, give your customers what they want. So before building any software, go and talk to your customers. Ask them what do they want in this software and list out all the use cases which you can come up with so that once you build it, it's doing what exactly your customer want. So once you deliver your product with the initial requirements, then your customer might be coming up with new requirements. And it's your responsibility to keep your customer satisfied by adding those new requirements to your software. Whenever you are building any software, you have to take use cases, you have to take those requirements from your customers, and you have to perform a deep analysis so that you are building a product which not just works in your environment but it actually works in a real world context. It's actually covering all the use cases in the real world and it is able to handle all type of tasks, all type of requirements of your user which they initially gave you. Now second point is object oriented principles. So how you should be writing your code. So you break your big feature into small features and then you focus on each individual small feature and perform the required analysis, build those small features, and then those small features will be contributing to your bigger feature. That way it will be easier to develop. No duplicate code. If you follow object oriented principle and ensure that there is no duplicate code in your software, then it will be easy to update and maintain in the long run, because you will be using some common codes for a common requirement somewhere in your code, and you will be not be duplicating that at multiple places. So whenever you will need any update, you will just have to update it at only one place rather than updating it at multiple places. Flexible and resilient design. So your design should be flexible enough to incorporate any new changes which will be coming. So your customer might be encountering new problems and they will be asking you to make changes. So your code should be able to handle those requirements without much change, without much redesign, and it should be resilient enough to handle the real world task, to handle what can go wrong. Next point is low coupling and high cohesion. So your module should be very less dependent on each other, which ensures they are very low coupled, and they should be highly cohesive, which means each module should very well know the job it does and it should have a well defined job. That way, it's easier to maintain in the long term. Now, coming to the design principles. To build a great software, you should have a very good knowledge of design principles. You should have familiarity with what problem a given design principle solves, so that whenever you encounter any problem in your software, you can refer any existing design principle if it can solve your problem. That way, you won't be spending too much time on solving a problem for which we already have a solution. That way, you save time and effort. Now, iterate and improve. So, you take your software and you break it into pieces. You have those small pieces, and you pick one piece, do the deeper analysis, and build it, cover all the things which it should do, and iterate over the next piece, and then you combine those pieces to build your bigger product. To build your software, you can either follow use case driven development, where you pick a real world use case scenario and you develop on the basis of that, or you pick a feature driven development where you pick a specific feature in your software, like let's say search, or let's say user login, and you develop that first. Or but in the real world, we actually follow a combination of both. For some things we follow use case driven development, and for some, and then for that specific use case you can split it into features and follow feature driven development. So in real world, it's actually a combination of both. For each use case or feature you are developing, you have to perform a deeper analysis, so that you are covering all the possible things, all the possible ways in which it can be used. And at last, write test case scenarios, so that you are testing real world problems. So you have to write test the way, each possible way in which user can use your application, all the possible scenarios in which you can have wrong inputs, all the unexpected things which can occur, all the errors which can come up. So you have to have a very good test coverage for all these type of scenarios. That's all for this lesson. If you liked this video, please like, share and subscribe. Thank you.